To find the particular solution of this differential equation with the initial condition y not equals to 0, we see that this is a first order ODE where we can use separation of variables, just because we can put terms with y on the left hand side and then terms with x on the right hand side, and then go on and integrate. So when we do that, we have dy is equals to 1 divided by x squared minus 1 dx, and then go on and integrate on both sides. But now when we are looking at the denominator here, the x squared minus 1, we see that this is a difference of 2 squares, so we can try to rewrite it. When you are having a difference of 2 squares, a squared minus b squared is equals to a minus b multiplied by a plus b. So in this case, we are saving a 1 here, 1, and that's 1 squared, so it's x squared minus 1 squared. So when we use the difference of 2 squares, our right hand side becomes the integral of 1 divided by x minus 1 multiplied by x plus 1 with respect to x. So we now have this integral, but to evaluate the integral on the right hand side here, we will have to use partial fractions. So for partial fractions, we look at the fraction that we are having there, 1 divided by x minus 1 multiplied by x plus 1. What you can see there is we are having linear terms, so we can write that as a divided by x minus 1 plus b divided by x plus 1. And then put under a common denominator, and then we have a times x plus 1 plus b times x minus 1 divided by x minus 1 times x plus 1. Now when we look at the fraction that we had initially, this one, and compare with the one that we have now, what we see there is the denominators are the same. So if the denominators are the same there, we are saying they are equal, so the numerators should be equal. So we have a multiplied by x plus 1 plus b multiplied by x minus 1 is equals to 1. So we can now go on and use this equation here to solve for a and b. So to do that, we can try to eliminate a, then solve for b, then eliminate b, then solve for a. So what you can do there, if we substitute x equals to minus 1 here, then this part becomes 0. So we remain with minus 2b is equals to 1. Then solve for b, we have our b is equals to minus 1 over 2. Now we go on and eliminate the next part here. If we put x equals to 1 here, so we're saying x equals to 1 into the equation that I've highlighted there, we would have on this part it to be 1 plus 1, which gives us a 2. So we have 2a is equals to 1, just because this part becomes 0. We then go on and solve for a there. We have a is equals to a half. So now that we have found the values of the a and the b, we go on and substitute these values here into this part here, so that the right hand side of our equation here becomes the integral of 1 divided by 2 times x minus 1 minus 1 divided by 2 times x plus 1 with respect to x. So that's the integral that we have there. I'll then go on and look at this integral here. The integral of 1 divided by 2 times x minus 1 with respect to x is equal to a half multiplied by ln of the absolute of x minus 1. Then on this part here, we are having the integral of 1 divided by 2 times x plus 1 with respect to x. The result that we get there is a half multiplied by ln of the absolute value of x plus 1. So substitute into our equation here. So on the left hand side, when you integrate 1 dy, it gives us a y. So we have y is equals to a half ln of the absolute value of x minus 1 minus a half multiplied by ln of the absolute value of x plus 1 plus c. The c here is a constant of integration. It's just a real number. But when we then go on and look at the equation that we are given an initial condition here, y naught is equals to 0. What that initial condition is saying is when x is equals to 0, y is equals to 0. So we substitute it into the general solution that we have just obtained here. So wherever we are having y, we put 0. Wherever we are having x, we put 0. And we have 0 is equals to a half multiplied by ln of the absolute value of 0 minus 1 minus a half multiplied by ln of the absolute value of 0 plus 1 plus c. So these parts here we just simplify to ln of 1. ln of 1 gives us a 0. So we just have 0 is equals to 0 minus 0 plus c. So we would have c is equals to 0. So that's the constant there. We have found its value. C is equals to 0. Substitute it into our equation here. And we have y is equals to a half ln of the absolute value of x minus 1 minus a half ln of the absolute value of x plus 1. So what we are having here, this is the particular solution of this differential equation given the initial condition y naught is equals to 0.